Hello, I'm Davin. I'm a course director here at the University of Staffordshire.
Hello, my name is Jennifer Challenor. I'm a character art lecturer here at the University of Staffordshire.
And today we're going to be looking at making a client-server architecture. I've got a framework here set up, kind of ready to go. If I just hit build, you'll get a vibe for sort of what we've got going on. This login button currently doesn't work, but we'll leave that for a moment. But you can see here that we have a ball. We've got like a reminiscence of Pong, sort of. So not doing loads, but this is all obviously just running off of one single application at the moment. There's no network traffic going on at all. But I'm going to go back to the code. This is actually made in Monogame, so it's using C# and Monogame to kind of get the framework up and running. Monogame basically just doing the graphics for us.
Okay, fair enough.
There's a bunch of other code behind the scenes for kind of what's going on, but you don't really need to worry about any of that. That is just for the framework for graphics and all the other kind of stuff that we've got going on. So I'm going to be working mainly in two files here, which is my server and my network manager. Right? So if we look on the far right, if you're used to kind of a solution explorer in Visual Studio, you'll probably find that you're normally used to just having one of these. So these are our projects. So right now I've got three projects going on. One is the game framework, effectively. One's a packet library, and the other one is our server. So you can imagine that the framework could be sitting on another computer, and the server could be sitting on another computer, and we can get those two things communicating together. Now, obviously, we're working on one device right now, which is obviously a bit of a problem for demonstrating multiplayer-based things. But we're going to trick the device effectively into thinking that we're going to throw data over the network.
Excellent. Light of the machine.
Exactly. So that's what we're going to be doing, right? So,
just a quick point before we get in. I'm noticing a distinct difference in how we approach code because I don't see a single comment on there.
There's comments throughout the framework, but so if I go somewhere in here, you'll probably see some comments somewhere, maybe, I don't know. Yeah,
so, some comments somewhere,
potentially,
maybe.
Not in there, but a lot of stuff's behind the scenes. So obviously you should be commenting your code, especially if you're making frameworks, but yeah, that's not what we've got going on right now. Okay, cool. So Jennifer, how much do you know about networking at all?
I've got a little bit of experience from when I was doing my PhD project, but I won't lie and pretend I've got extensive knowledge of this.
Okay, no, that is perfectly fine. Right. So .NET, so C#.NET has a lot of built-in functionality for us, which we can really leverage to kind of get this thing off the ground effectively. So we don't have to kind of worry too much about going all to the intricacies of doing something that's really, really low level. But the important things we need to kind of understand before we do begin is things like IP addressing. Now, if you're looking at your IP address kind of at home, you're more than likely going to have one which is like 192.168.0.1. And that's because that's a local Class C address, effectively. And what that means is when we have these private addresses, we can just share data, amongst those things. So like amongst all your home devices. And we can all have that same IP address regardless of which network we're on because they all connect to our public IP address, which is another kind of IP address that we go forward. But what you effectively need to know to make this work is we need an IP address to send this data to.
Correct.
Now, when I first started learning networking way back when, my tutor at the time, he told me this really awful program, like this networking joke, effectively, and it's called, there's no place like 127.0.0.1. And the IP address of 127.0.0.1 is effectively a loopback address. So it means that we're going to send data out and it's going to come straight back to us. So effectively the joke is there's no place like home, but done in an IP address for networking. But it's always helped me kind of remember where we're going with that sort of thing. So going back to kind of our code base here, we have a thing called a TCP listener. Now, TCP is a form of sending data over the network.
Okay.
It's a transmission control protocol, and it's kind of like a handshake scenario. So I'm going to send data to something, and it's going to send me an acknowledgement back. So if you think when we're downloading a file from the internet, we have to request that data. It then sends us something back to us, some of those files, and then we tell the server we were downloading it from, like, hey, we got some of those files, can you send us more? And that's effectively what we do. And we have this kind of like handshake protocol, and you'll notice when you download files, it gets quicker and quicker and quicker, and that's because that transmission is trying to find the speed that all devices on that network can handle basically for handling that. Whereas there's something else called UDP, and that's kind of what like Twitch will use, for instance, like live streaming devices. So we're just, for UDP, we kind of just throw data at the device. We don't really care if it gets there. So there's no handshake protocol, but for today, we're going to be using TCP because it's a lot kind of easier to kind of use. Games do typically use more UDP stuff, but for anything where we want to guarantee that transmission going across, you would use TCP for it.
Okay, so without going into overly technical terms that would go completely over my head,
Go for it.
Are there any advantages to using TCP over UDP for games?
So like TCP is guaranteed.
Okay.
It has a lot of like built-in handshake stuff for you. So you can if I'm going to send data to somewhere, I'm one game client and I want to get another game client to know my position of my player, I can send that over TCP and I can guarantee, assuming the connection's working, that I'm going to get acknowledgement of that. If I don't get acknowledgement, I know there's something wrong with the network. Okay. However, it's slower. Whereas with UDP, we can actually build some of that stuff on top of it, and some games do actually do that, but that's obviously a lot more dev time to kind of do that, and there's a lot more kind of intricacies with it. But what you would typically find, anything that we need, so like logging in, sending like scores or anything like that, anything where data needs to match, we do it by TCP. If it is things like movement or anything like that, we're going to send another packet in another frame anyway. So if that gets lost over the network, it doesn't matter. We can just send another one in. We're going to get there.
That's fair.
So anyway, yeah, we have this TCP listener. This is something that's built into .NET. And what we're effectively going to do, we're going to try and get this to connect, right? We're going to start having a listen server going on. So I have a few different things here. We have a couple of functions, and we're going to start to fill these in. So in my server, I just want to initialize my TCP listener. And like you do with kind of any sort of like programming, we want to give it a value here. So if we kind of click in here, we can see that it is after a port number. So we can actually kind of connect it up if we want to do that. I'll look at doing that. So we've got this port number and this IP address up here. Now, actually, I haven't actually covered port numbers. Go in a second.
Goodness, ports. I think flashbacks to my teenage years. I used to run a Minecraft server for my friends.
Like that. So if I go IP address parse, so I'll explain that in a moment. So from a string, so we are parsing the IP address, and effectively all that's doing is pointing to the right format that the TCP listener is expecting, because the IP address actually has a bunch of other random things behind it, which we're not going to get into today because that would go a bit too much into kind of overkill with it. Port, effectively every single networking thing that's like software that's happening on your machine has a port listen to. So for instance, when you open up your internet and you open up all those different tabs, each one of those tabs will have a port associated with it, so that when we request data to that web page, it knows that the computer knows where to send that data to, so it knows where to kind of display it. For this, there's a couple of reserved port numbers which we don't really touch, but for this, I am just going to use the port number of, let me just open this up, it should be 4444, that's what I'm sending over. Doesn't really matter, that could be anything else, but I'm just saying my server's going to listen on port 4444. And we're going to get ready to go from there. So I've initialized that. Don't worry too much about this just yet. We'll go over that in a moment. Okay, so now I've started that up. The next thing that we want to start doing is actually we want to listen in for incoming connections. And the way we do this is if we go to the TCP listener again, obviously we kind of want to start that. But then after we've started it, there's this thing called accept sockets. Now, sockets are effectively that software connection of our networking. So it's going to contain all of that information, your port number, your IP address, and kind of any other kind of metadata that's needed. So when I go accept socket here, I can actually store this as a variable, like such. If I spell it right, that would be handy. So what's going to happen is my client is going to try and connect to this server. And the server is currently waiting on this line of code. This is actually a blocking command, which if you've done any kind of programming before, you'll probably get used to. We just go line by line by line by line. Yes. And we don't really wait for anybody. We just keep going, and the computer handles that as much as possible. However, there are certain functions like this, like accept socket, which we call blocking. So what this is going to do is it's going to say to the server, let's just stop right here, right? We're going to wait here until we get a result. So you may have come across this before. So like when we do console.readline, right? When we're waiting for a user to type into a console, that's also a blocking command because nothing's going to happen until we press enter on the keyboard. So that's effectively what it's going to do. So until a client tries to connect to our server's going to stay there for now, which is exactly what we want, right? We don't want the server to do anything else. Obviously, a more complex server would, but now we don't want our server to actually do anything else from here. And once we have this, we can do a bunch of things with it. But I'm just quickly change this because we can do this stuff later. See how far we can get. Once we get that socket, I'm actually going to put this into our client method because I'm just going to, I want to keep my functions nice and tidy, so we're going to kind of go through those things. So I'm just going to pass in that socket into there. Tell you what, let's quickly fill in the stop command. Well, we've got a server here to start.
Yes.
Obviously, we might want to turn the server off at some point.
Might want to, yes.
So we'll just go TCP listener, stop. Now, the IntelliSense actually put in this question mark into our variable here, and all that's saying is, if it's not null, stop it. Yes. So if it actually has a value, we're going to go for it. But that's what stop does.
So just a quick question before we carry on.
Go for it.
When I'm writing code, I'm a bit paranoid that I've done something wrong, so I'll often put lots of print commands through it to specifically say server has started, server has stopped, etc. Do you ever do that, or are you confident that you don't need that?
No, I mean, I definitely do that kind of all the time. And we can do that now, right, if you want. So we could go like console.writeLine, server has started. And then here we can actually assume, well, we actually know, so we don't need to assume anything, that a client has connected. Right, so we can do that. And then once we kind of, obviously we could do one for stop, but that's okay now. But yeah, you can do these console.writelines. Now, the problem with console.writelines is they're actually a bit slow. So in production code, we don't really want to keep them in there. Yes. But yeah, obviously we can do debugs and all that sort of stuff. But obviously when you are debugging, it gets really handy to use the debugging features inside of Visual Studio, which hopefully we're not going to need them today, but we probably will see, right? Because you know, when you're coding, something's always going to go a bit stray. Now we have our socket. So when we have that socket, we have that connection between the client and the server. And what we're effectively going to have from here then, we're going to have something called a network stream.
Okay, what does a network stream do?
All right, so let me just set this up and then we can go over that. So a network stream is, someone once described this to me as a tube, effectively. A tube that we're going to send data through.
Don't you dare tell me the internet is not a big truck, it's a series of tubes. My heart can't take that, not again.
The internet is a series of tubes.
No.
Unfortunately. Or fortunately, it works, so that's all good. So yeah, a stream is, you'll see here that what I've done is I've generated a new network stream and I've attached this to our socket. So the network stream is going to take all that data from the socket and start to create that tube of data, so it knows where the endpoint is and it knows where the start is. And what we're effectively going to do is just throw data down that tube and receive data from it, and we're going to do this like back and forth kind of process. So to be able to read from a network stream, we use something called a stream reader. And to write to it, we actually have a stream writer. It didn't suggest a variable name for me that time. There we go. I normally call mine just writer and reader, so I'll change that top one in a second. And you'll see, again, I'm passing that stream into these things. So it knows which stream the stream reader and the stream writer are related to, right? So we know we can actually jump on those things. So let me just do that to reader. Okay, so now that we've got that all up and running, there's a couple of, what we want to do is effectively send a message to the server or receive a message from the server, effectively. Sorry, from the client to the server.
Yep.
But there's a bit of functionality that we're going to do here. And first up, I want to have a message. So string, and this is just going to be my variable that I'm going to actually keep using throughout all of our kind of like messages. So I'm just going to keep recycling this same one. And all I'm going to do here, it's going to be a while loop, because effectively once we're in this cycle here, we want to be able to send and receive messages endlessly, right, until something's closed down that connection, whether we've told we send that manual sent over, or something's gone wrong and it's just going to kind of collapse in on itself. Ideally, we want to do some kind of protections on those, and there's a bunch of things that we can do. We can potentially have a look at those a little bit later, but let's obviously keep going through from this. So
when you say protections, is that things like if, say, if a player was sending, say, their login information to the server, we'd want to protect that?
We would want to protect that. That's not what I meant by that case. So what I was on about was defensive coding, effectively, where we want to, if an error was going to occur, we want to be able to try and catch that error effectively. What you're referring to is, obviously, we want to encrypt that data.
Right, okay.
So we don't want to be just sending base passwords through the network, right? We don't want to be saying, hey, my password is hi, right? What we'd want to do to that string of hi is we would want to really encrypt it. We can do encryption, but encryption's it can be really slow. So you do want to encrypt all data to some degree, but things like passwords you want to encrypt to a higher sense of higher degree, right? So you want to. But it takes longer to encrypt and longer to decrypt. So you wouldn't be sending super secure data of like the player's position over the network, but you would still secure it somehow. So you would still do a small level of encryption on it.
That makes sense. For people watching at home, I'm on the art team. I don't normally deal with this type of thing. I hear protection, I just immediately assume it means network security.
So nope, that's perfectly fine. So this next line of code that I've just done here is, I'll read this out to you right now. What we have effectively done here is we're going to do a while loop again because we want to do this endlessly. And the condition of this while loop is we are going to set the value of message to whatever the reader has read from our network stream. However, we've wrapped that up in brackets, so it's going to do this first. This message equals reader.readline. And it's going to do this until we receive a null value. And the reason it's going to go null at some point is this reader, when the stream collapses, so like if we log out or anything like that, the stream's going to go to null, which means the reader will go to null, which means this would go to null. So it kind of has that cycle through. But what this is doing now is, much like with this line of code, this accept sockets, reader.readline is another blocking command. So until the reader actually has a value to take from the stream, our code is going to stay at that line of code. So we don't have to worry about doing anything else, because we can just safely say our server is going to wait for this line of code to happen.
Okay.
And so what we're going to do here then is we are basically going to, in fact, let's just go console. We can pause for a second actually. Console.writeLine, message from clients, and then we can actually just go like message, right? Actually, we can just leave it here for a second on the server side, because what I want to hopefully do is send a message through the client.
Okay, so we're going to give that a try and see if it works, or we're going to write the code for it?
It's not going to work just yet, because my client's not done. So we've done our server, but we actually haven't done our client. Now, some of this stuff is a little bit set up, but not a whole chunk of it. So we have our network manager, which we've got open there. In our menu scene, just for highlight what's going on, we have a login button, which obviously you saw when I loaded up the, in fact, if I just quickly load up again. There you go, so I've got a login button. At the moment, you'll see that it's actually commented out. It doesn't really do a whole lot other than enabling the play button and telling the network manager to kind of log in. But if we go to the login function, the login function's not really doing anything. It's just it's a code snippet for the moment. So I'm just going to uncomment this. So what this is basically saying is, hey, network manager, try to connect on the IP address of 127.0.0.1, again, so our loopback address, and most notably, it's the port number of the server. So .NET's going to generate a port number automatically for the client. It's going to be some random number, like 53,468.
Oh my goodness.
Something like that, right?
All the ports.
Just random things like that. And that's going to be kept in kind of that socket, so the socket knows kind of the endpoint and all that sort of stuff. But because the server is on a static port, we know what port number to try and connect to. So I've enabled those for now. We can actually enable these as well, just in case. But we're going to go to our network manager. Now, the interesting thing here is that it kind of works in the same sort of way as the server did, except for we'll just kind of basically flip some of that stuff over. So it's nice and fun to kind of have a look at doing that. So connect, obviously, just false at the moment, and we're going to have this thing called a TCP server response. But Inside of my network manager, we have, in fact, let me just stop playing a sec and go to the network manager. Right, so inside of here, we are going to have, in fact, actually, before I do that, we have this thing called a singleton pattern. This is a bit naughty. You don't really use these too much in code. It gives us a global access to our network manager. So very, very handy. It means anywhere on my code base, my client framework can use features on my network manager. So it's going to make coding some of this a little bit later on a bit easier. However, a singleton is a bit dangerous because it gives global access to these functions. So you don't really want somebody to be able to come in into your audio system, for instance, and start to try and communicate with your network manager, right?
Right,
so,
okay, yes.
So if we're working in a bigger team, you probably wouldn't want to do this sort of thing. It's a design pattern, it has its time and place, but we use this for a bit of easy access right now. Anyway, so I'm going to have my variables up here. In fact, let's leave the instance up there. So on the client side, we have this thing called a TCP client. Okay, amazing, right? So it's the reverse side of what we're doing. So I'm going to do my TCP client equals a new TCP client. Again, I'm just instantiating it so it has a value, and we can kind of go from there. Now, we want to try and connect, right? So we're going to use the TCP client.connect function, and we're just going to pass in that IP address and that port number that you just saw a moment ago with the login button. So the login button is going to get pressed, it's going to go to this function, and then it's going to return this TCP connect. And then we can actually just return here TCP-client.connected.
So in this context, the login button's controlling both the 127.00, etc.,
yeah, so
and the port number. In other applications, might you want to define that as a variable so that you can choose which server to connect to?
You definitely wouldn't hard code it like I have.
Yep.
You would have that in some form of either file or somewhere kind of enclosed. But what you'd really want to do is that probably needs to be kind of protected somewhere as well. You don't really want to just have that just randomly in the login button, but you would just use that somewhere in the code. So it's not something that you're necessarily going to be changing all the time, because obviously our servers are going to have static IP addresses, right?
Yes.
So we kind of know where to go to kind of connect to them, but you wouldn't just have it just sitting in plain text, for instance, in that login button. You would have it, as a variable somewhere or in a settings file or something.
Of course,
like that.
yeah. I mean, there are valid cases of hard coding stuff as well. I mean, when I was working on my PhD project, one of the things I needed to do was, again, a network manager.
Yep.
The framework I was using, which was Mirror for Unity at the time, had it was a class that came sort of built in, and used that to define the IP and the password. As where in mine, because I knew I wanted it to connect to the same one every time, and because I was doing it with a HoloLens where you couldn't conveniently type that in every single time, I just had it. I made a variant of the network manager, which was a custom one, that instead of asking for that information, it was hard coded and it would automatically execute when it ran. Yeah. So
exactly. So
handy uses for it.
Okay, right. So we've got these two functions here. There's TCP process server response and there's TCP send message. Send message, as I'm sure you can imagine, going to be used to send a message. And the TCP process server response is going to be used to kind of read that data kind of coming in. So first up, I'm just going to use my login, and all login's going to do is going to go TCP send message, and then I'm just going to go like hi server or something like that.
Oh.
And then what this is then going to do is, in fact, we need to set up our reader and writer, which we nearly forgot to do. So we're going to have our stream, so our network stream. Just going to call it stream here. Network. Sorry. Stream. And then going to have my stream reader. And stream writer. I'm just going to call this my writer. There we go. And when we actually connect here, what I'm going to do actually is if connected, we are going to set those things up. So the stream now, whereas before we actually manually made a stream on the server side, we can actually pull that stream from our TCP client. Oh, there you go. So it's doing it for us. So because the TCP client's connected to a server, it currently already understands that stream, and we're just going to store that as a variable. And then for the reader, we're going to do the exact same thing as we did in the server. Basically, we're just going to connect them up to that stream that we've just made. So now that we have those, what we should be able to do here is go in our writer. Choosing a name convention I'm not currently using. And I'm going to write line message. Obviously, hi server, message going into there. And then I'm going to go here, writer.flush. Now, this flush is really important because what this basically does is it cleans that writer out, right? So it basically gets all the data in the right line and then just basically pushes it across to the stream. So we get the data and then flush it through the pipe.
Why do they use the term flush?
I'm not too sure the etymology of that one, but I suppose it is because you are just like flushing it through. So yeah, that's what we're going to do there. So let's give this a go and see if this works. Now, I'm going to open up the debug. So I'm opening up a server window. Just take a moment. And you can see there, so server has started, which is always a good sign. So I'm just going to put that up there. And then in the other one, I am going to start this as well. And hopefully, when we hit this login button, we should see client is connected up there. We do.
Hey.
And it says hi server. So we can now safely assume that those two things are connected. So what we can do on the other side then is effectively respond to this message in our server to our client. So we could then go like message, right line, we could go like hi client. And then again, we're just going to flush it. And we're done. So going back to here, we're going to handle this stuff here. And what I'm going to do is the exact same thing as we had before. So in fact, yeah, let's go while. Yeah. So string, message, and then while, next bracket, message equals reader. There we go.
There's an awful lot of tapping coming from the keyboard today. We could have put a little micro next to it and turned it into an ASMR video.
Oh, that would have been nice, wouldn't it? A nice mechanical keyboard. So again, same thing we had before. And for some reason that's erroring. What am I missing here? Oh, bracket there. There we go. So what I'm going to do here is exactly the same as I had, but because with Monogame, we don't actually have a console, we have a game that's run up, so it's not actually running through the console. So we're going to use a different debug message over the side, and we're going to use the thing called debug.writeLine instead. And all that's going to do is it's going to put that message out into this debug window instead down here.
So instead of seeing it in the window, we'll see it in the editor, yeah?
Yeah, okay. Exactly. Now, this is not what we want to do at all. I am going to break something when I do this right now, but if I go to TCP process server response, and we'll explain kind of what issues are going on when I build this in a second. Now, obviously, before I do build it, you noticed I actually had to manually open up a server, then I had to manually open up a client. We can actually do a shortcut. If we click up here in Visual Studio, click here in Visual Studio, we can configure our startup projects. So we can go multiple startup projects, and then I want to hit run on our server and on our framework. I'm going to hit apply, and I'm going to go OK. So now when I hit start, you'll see that it says multiple startup projects. Both of those windows are going to open up. So it saves me a bunch of clicking around, which is always nice. So if I hit login, hi from server, and we've got hi client. Now, problem though, we're all froze up. So, and that's because we're now stuck in this while loop.
You didn't put an exit condition.
There's no exit condition, but really we don't want an exit condition here because we want our client to always be able to read from the server, right? So we always want it to be able to receive messages at any given point. So this is where things are going to get a little bit more potentially complex. What we're going to do is we're going to introduce threading. So obviously all modern PCs now have multiple core processors which have multiple threads kind of within them. So we can operate multiple things concurrently to each other. So what we want to have running is we want our client to be able to send data at any given point, but also receive data at any given point. And we don't want those two things to interact with each other, interfere with each other. And threading primitively is quite simple in C#, which is quite nice. So what I'm going to do here, I'm going to create a thread. I'm just going to call it listen thread. Don't really need to name it too much of the variable because it's only a temporary variable. And this is going to be a new thread. And there's a couple of ways to actually start these threads up. But I'm going to do something called a lambda effectively. And what a lambda is, it's like it's a anonymous function basically, where we pass in a function as a variable, and then it can kind of just do whatever we want to do from there. So I'm going to add in this function up here. So if I go TCP process server response, and then do that. Now that's basically saying is, in fact, to make this a bit clearer for people to read, we could basically do it like that. So we go, okay, we want to start this thread. We're going to pass in this scope of information into this thread. And now this listen thread understands what lines of codes it needs to run because it's going to do those things. And I can just go listen thread dot start. So now we have this thread that's currently just listening out constantly for the process server response. So I'm just going to get rid of this line of code here because we don't want to do that anymore. And hopefully, in practice, we shouldn't freeze up this time.
Fingers crossed.
Fingers crossed, nothing's gone wrong. So I'm going to hit login. We've got hi clients. We can still move.
Hey.
And we can keep going. So what we could do to kind of test this even more is if I go back to my server, let's just do a very quick like for int I equals 0, so I is less than like 10.
Yep.
I plus plus, so a nice simple for loop. And let's just send over the network I. There we go. And then just writer dot flush. So what this is going to allow us to do, now that we've threaded our client, it's going to allow the client to receive those 11 messages all in one go, the hi client and the 10 eyes, basically.
Now, just because I am a child and would therefore want to click on buttons, when you clicked login the first time, we saw that it worked. What happens if you clicked it multiple times? Would it just keep saying hi server or?
No, we're going to get some errors.
Excellent.
And that's because we haven't got that defensive programming in where we're not turning off that button. So the button tries to connect to the server again, and there's no code in place at the moment to stop it from trying to connect. But because the TCP client has already got a connection, it's going to go like no, and it's going to cause some errors for us. So in practice, what we'd probably do here is try to stop that functionality from happening. And we could do that by essentially going login button dot enabled equals false. So now we shouldn't be able to run that twice.
Brilliant.
So we no longer press that. But if we go down to this debug menu here, we can see that we actually received multiple messages, which means we've actually started to kind of connect, which is fantastic. So the next thing that we need really for a multiplayer game, we've got our ability to send messages over the network. The next thing that we need really is, well, we need our server to be able to handle multiple clients. Well, if we go back to our server code, what we do here is we start it up, we accept a socket, and then we go onto our client method and then get stuck in a while loop. So we can use the exact same logic that we just used, and we could do all this on threads, effectively. So for every single client that connects to our network, we're going to put it on a new thread. So the server can just constantly handle all of these clients that are connecting. So in theory, we could handle infinite. In practicality, obviously we can't because the hardware is limited. So however much threads and processes we had on our machine that we're using is how many we could run concurrently from each other. But the CPU does some really clever things like context switching, so we could actually boot up more threads than we have, and it just swaps between them. So it seems concurrent, but it's not effectively. And that's the cool thing about threads. But anyway, let's have a look at this. So let's create another while loop here, and let's do this infinitely. I always like a good infinite loop.
So it's always the catastrophe.
We've got our now infinite loop going on, and we have our accept socket. We have our client method, all good. So this is going to go on forever. But obviously, at the moment, we are still going into this client method. We're still going to get into another loop inside of that. But what we effectively then want to do is put this function here onto a thread. So we go thread. I'm just going to call it thread equals new thread. And again, just to make that super clear and formatting wise, we're going to go there.
You can tell your experience with this because you know all the hotkeys to get that lined up perfectly.
Just typing. Visual Studio does so much for you now, it's fantastic. But anyway, so now, in theory, what could happen, or what should happen, is that we can connect multiple things to our server. So client's connected. Did that do its thing? Oh, no it didn't, because I forgot to tell the thread to start. So it never actually started the thread. Let's try that again. Login, there we go, so we've got that going on. But if I go back to my Solution Explorer now and do another debug, we can hit login again, and we've got another one connected there. And you can see there, our server's now got 2 clients connected to it, which is amazing, right? So we can do that. Problem is, though, at the moment, we're actually going to lose track of those clients. As in, like, the code base knows they're there. As in, like, they're still going to be processed. They're going to function okay. But if we want to try to send a message to one of them, we're not going to be able to kind of do that just yet, because client 1 and client 2, there's no reference to each other for them. So the server kind of loses them, because we have this thing called a scope here. And once we leave the scope, which we're going to do, all this information is going to go to hidden in memory, basically. It's still going to be active because the socket's still being used and the thread's being used, but there's no way for me to get that information back.
Yes.
So I just need to store that. And obviously I can do that in a variable.
Yes.
And we're going to use this thing called a concurrent dictionary. And a concurrent dictionary is effectively it's a dictionary. But if you don't know what a dictionary is in C#, it's like an array or a list, but it uses a key value pair system. So, and what we mean by a key value pair is we have a key, a unique value, and it's going to pull out its corresponding pair. So, for instance, I could have a one for like people, so people and age, right? So I could put a string and integer in there, and it will go. I could put my name in there, so Davin, and it will come out with 33, and it just have that. And we can have as many of these, but the key has to be unique. So that can be our client ID.
So forgive me for using a metaphor here, just trying to contextualize this in my head. Would this be like a hotel registry where you've got the name, but the name is associated with a key number for which room you're in, basically?
Yeah, effectively. So we could have that key card in the door, basically, for the hotel.
Excellent.
That's a good one. So, but anyway, so we have this this dictionary. The reason why we're using a concurrent dictionary in this example is because we're dealing with threads. Now, there's a lot of things, we could do like a whole hour talk on threading and more. So, but there's a lot of kind of things that happen behind the scenes. And whilst you want to be able to use data from each thread, so obviously we're going to try and get these 2 clients speaking to each other, I'm going to get references and all that sort of stuff. There's this thing called like race conditions, right? So if one of my clients was updating and another client tried to interfere with some of that data that it was using, we could overwrite it. And we don't want to override it while it's still processing information. So we can do a bunch of things ourselves to try and protect some of that stuff from happening, and good multi-threaded architecture does that. But C# has a bunch of these collections built in already that has some of that security baked in for us. So when we try to pull a client out of the dictionary, it's going to check whether it's being used at the moment or not.
Makes sense.
So it's super helpful to use. So first up, we are going to initialize it. There we go. And then from here, what I'm going to do is, you'll see here, there's actually called the connected client. It's actually another class that I've got going on. Okay. And this connected client actually has some of this information in before, so I'm just going to very quickly copy some of this stuff over so it's all in one place. I'm going to neaten this up, so I just took all of that data we got there. So my network stream is in here now, so I'm just going to quickly take that. There we go, and sort that out. And then what else do we need? So we need potentially to have our read line. I'm just massacring the code at the moment.
I guarantee you anything you do here is not as bad as what my code looks like on a daily basis. I very rarely do any programming, but when I do, it's messy. It's very messy. There's a reason why I'm not showing my code off.
So read.readline. The reason why I'm just putting these in here is because I want to try and create some object orientation in our programming effectively to be able to reuse some of these functions. Because obviously now we're going to have multiple clients all working. And so now all I've done is I've got a function for send, which wraps up the write line and flush. I've got a read function, which returns this reader.readline. We can do some more with this, but we'll just leave it like that for now. Close, we don't need to worry too much about that because we're not going to get around to it at the moment, but have this network stream in here. So we've effectively just massacred our read-write function. But now all it's going to be is, in fact, I'm going to turn this back to my integer that I had before, and ID, and it's going to be my mClients. Again, I'm just pulling that client back out. ID dot read, right? So same function, just updating it. I'll update the other ones in a moment because I want to get onto this bit first. So the connected clients, we need to make one of those up here. Right? We accept a socket. We want to create a connected client class. So connected client, client equals new connected client, and this takes in our socket. So it's going to keep hold of that socket information for us. And then we are going to actually create an ID number. Now, in practice, you wouldn't do an ID number that just counts up from 0 onwards, because that's not very secure anyway. I'd be able to guess other people's ID numbers, so you'd have a more complex system. But for now, we're just going to use this integer of 0. And we are going to add our clients into our dictionary. So try add the key, so I need to pass in, let me give this a name, ID. So we're going to pass in the ID and then clients. So it's going to add it to the dictionary. And then instead, now I'm just going to pass in ID into my client method, and it's going to do its thing, right? So now we've got them all stored in that dictionary. Another quick thing with this, why this actually won't work, is because there's a difference between value type functions and value type variables and reference type variables. Now, a value is, if I say I had a cake, right, and I gave you the cake, but it's a value type. When I gave it to you, you're actually going to duplicate that cake. So we're going to have 2 cakes, right? If it's a reference type, I would give you that cake. You could cut a slice off it, and it'd also update my own knowledge of that cake.
Is it vegan cake?
It is vegan cake.
Excellent, thank you.
So we need to actually just quickly put this into a temporary variable, because when we do a lambda, it actually turns these value types that we normally have as integers into reference types. So I'm just going to very quickly temp ID equals ID. I'm actually going to increase my ID as well, so because obviously the next one's going to come around and use it.
Yes.
And now I'm just going to put this as my temp ID. So temp ID will be 0, equals 0. ID then equal 1 on the next time round, and then we go equals 1, 1, 1. You get the idea, right? We just kind of loop through.
Makes sense.
So now instead we're just going to go. In fact, I'll just leave that right there for now. I'm just going to grab this and go. It's now send, isn't it? There we go. So I'm going to send that message, but obviously the message was hi client, and obviously it flushes it for us, and obviously this can actually be our count again.
You use code so smoothly, I swear. It just flows out of your fingertips.
It's what's that? What's that? String. Ooh, why is that not? Interesting. There we go. So it's just naturally just typing, right? Nice keyboard. Okay, so in theory, what we've just done is, let me go to that. What we've just done is allowed our server to have multiple clients connected to it at any given point. So if I just reload this, and obviously we've got to be careful of time here. Just want to make sure this all still works. And debug. So go again. Yep. That's all good, right? So where we could go with this is actually just very quickly. See if let's hope this doesn't cause an error. So I want to demonstrate that, and then obviously we can end the session because we're running out of time.
Of course.
So for each connected client in the client.value, so we're going to loop through that dictionary. What I want to do is if in fact I'll just send it to all clients. So client.send hello from
the other side?
From the ID, so there you go. But yeah, from the other side.
I will say, while you're putting all this in, this gives me a whole lot of other perspective about just quite some of the stuff that happens behind the scenes when you're playing a game. I never really gave devs credit for this, but every time you play a multiplayer game, someone's thought about this, haven't they?
Yes, yeah. Why is that not working? It's ID. I forgot that, I deleted that function. There we go. So we have ID. So what this should do in theory is when client 1 connects, it's going to send itself a message. When client 2 connects, it's going to send client 1 and client 2 a message. So let's give this a go. So log in, hello from 0, and then if I add the next one, debug, stop message, and I hit login, we get, there we go, hello from 1 and 1. So what we can see there is we've slowly started to build up that back-end system of our client-server architecture. We've got the ability to send and receive messages to a client. We've got the ability to listen in for multiple clients coming into our server as well. So our server can actually handle multiple clients now, which is all good. So where you'd go from here is you'd start to use those messages to control data control objects in our world. And you'd probably start to look into something like a serialization method. So, because at the moment we're just sending native strings, and strings are quite hard to sort of work with. So you could use something like JSON, XML. There's things like Google protobufs as well. So we can put all that data. So we can put integers, bools, and all that sort of stuff into a packet, send that over the network, and we could then say update the position of an object, and that's where we would go with that.
Makes sense.
Yeah.
Seems like there's a lot of room you could go from here.
Yeah, we could continue that forward.
Excellent. And if you were building a game, this is just one final question to close on. You're making a game with multiplayer as such. How long would you spend building this backend? So what's the rough time frame to get all of this working with any other features you might want? So
with networking, if you're making a game that is a multiplayer game to begin with, networking should be kind of one of the first things that you start to kind of architecture, because it changes the entire kind of code base, what you're doing. You've always got to be aware of the information that you're going to be sending over the network. And so I'd say your networking architecture is going to kind of take the time of the development of the game, really, because you're always going to be working in it. Now, obviously, the back-end stuff, if you're using an engine like Unity or Unreal, it has some of this stuff like built in, ready to go, so you don't have to worry too much about the lower end kind of things, but you're always going to be developing that architecture. You're always going to be setting that stuff up.
That's fair.
Cool. Awesome. So yeah, I think that's been a good introduction to a client-server architecture in C#. So thank you very much.
Thank you very much, everyone.